All right, everybody. Thank you guys for joining us, whether you're here in person or whether you're joining us on Facebook Live. This video will be archived later, so if you want to come back and watch it all the way through, if you can't stay on for the full time. But today we have Dr. Steve Higgins with UK College of Agriculture. Well, it's Cafe now. My bad. And he's going to be talking a little bit today about building up profits through engineering. So I'm not going to steal any of his thunder. He's got a lot of stuff to throw at you guys today. I'm really excited. A lot of things that he has to offer I actually utilize on my own farm. So please give him a listen. You know, if you guys want to, go back on Facebook, re-listen again. Thank
you very much. Okay, so this is going to be livestock engineering, saving time and money through simplicity and elimination. So this past season, as far as last year, we had a whole lot of mud. We had some mortalities. People were running out of feed and hay, and it kind of continued over into the first of the year. So as a result of that, basically I get a lot of phone calls. People actually want to call me up and have me address what I call a spot problem, or problems where you stop. Okay, so I'll give you an example. Here's as part of a guy's farm operation that we actually went to. So you come in the main road, here's the guy's house, and so I went this farm with the extension agent, and so you can see where he's feeding right in through here, you can see where he's feeding all through here, he's got some hay storage on the back, it's torn all to pieces, and he's also got gully erosion that's going on in here because it's continuously grazing. He's not really moving his cows. He's also got some feeding areas that's out in front of the house, and it's kind of just all unsightly, and it's not planned out very well. And so this is an aerial photograph of this guy's operation when I went to it like a month ago or something like that. And so then I went through Google Earth, and you can see basically he's been doing the same thing for quite some time, okay, over the years. Now Google Earth went back to 1997, and I got images going back to 1997 for this guy's operation, okay? And then he had 25 cows on the property, but I counted, not even trying, 20 ring feeders. 25 cows and 20 ring feeders. So anyway, what I did was I found out, or did this Google Maps. So basically, this is where he parks his tractor. He does have some hay storage in this barn, as well as he stores some hay over here in this field. But he is driving out one way, 1,500 feet, to set out these roll bales, which means when he's driving back, he's making what I call an empty trip. It's a waste of time, okay? And so what I recommended, or the thing is the cost of a poor production planning can be summed up as poorly designed products. And what do I mean by poorly designed products? Well, it's taken him a long time to finish out a calf because they're walking in all this mud. He's feeding more hay. He's wasting stuff, okay? He has low rates of production because his feed efficiency has gone through the floor because they're traveling in all this mud. He has high cost because he has to feed them more. Poor morale is kind of on the situation of the producer because he's got to deal with this drudgery, but it's also on the cow's part too, but most people don't think about the morale of cow. And disappointing consumers, whether you're doing freezer beef or basically just looking at it from the standpoint of, well, I want to finish out these calves and get them to market, but if they're walking through mud, you're delaying that time because of this drudgery. So since this poor planning is costing this guy's money, because as I was looking at where to do something on this guy's farm, he's visiting with the extension agent, and he tells them in all the years that he's been doing this, he's never made a profit. That's significant, okay? So what I recommended was basically, this is the Bo Renfro structure, which is available through state cost share. This is 36 wide, 50 feet long in concrete. This section right here is raised 6 inches to create a feed table, but it also keeps these roll bales out of this muck and this mire, okay? And then you use this structure to basically facilitate rotational grazing and moving these animals, but you also set up a hub, essentially, to do the feeding here where you're not driving out and putting a roll bale in a different spot every time. So, taking this same field, this red line basically dissects this field and creates two. You put the Bo Renfro as the blue rectangle right there. You pop in and right there. These two little rectangles right here are lanes, okay? Which means if his tractor is right here and his hay storage is right here, all he's got to do is drive essentially less than 200 feet to load this thing up with probably enough hay to last a week. Okay? He's not having to drive all the way out there. He's not having to do all that. He's dissected the field. He would take a water and he'd probably put in a water probably right about there. So you jump in. Here's another way of looking at it. So he's already got a fence here. He's already got a fence here. These two yellow lines are basically adding 2 additional pieces of fence to basically create this lane. So cattle can go out this way. They can go into this lot, which has got his handling facility. They can go this way. They can come around here. They can go to this facility. So he's got access to 1, 2, 3, 4, 5 different fields, plus his handling facility, plus it's close to his storage. And that's easy. I mean, that's what it is. This guy's been dealing with this since at least prior to 1997, and all of a sudden you show him an idea that basically is going to save him a lot of time, a lot of money, a lot of drudgery on the cattle. Okay? So the benefits and effect of production planning are seen in the reduction of production costs. So basically it's saving time and money through simplicity and elimination. And so here's another one. So this is another layout. So this particular farmer is doing this activity of feeding these animals, and his path is this red line, which seems very, very crazy and chaotic to me, okay? But the catch is you're missing the chaotic part. The chaotic part, it says, is repeat this 8 times, okay? So he's literally dumping feed right here, and then he's picking it back up again, and he's moving. He's got to go through all these gates and so on and so forth. And basically someone like me comes along and says, okay, here's your existing layout, just like that other farm. Let's change it. Let's change it to this, okay? So now he put in, this is called hardcore. That's an old term because this is like a 1940s, 1950s illustration. But hardcore is basically an all-weather surface. That's your geotextile fabric and your rock, that's your concrete pad, whatever. And now he's feeding off the fence line. He never has to really go into the pasture or the lot to get in with the animals, get knocked over, pushed down, whatever. It's the simplicity of basically saving him time in reduction and elimination of these other things that he was doing. So there's another idea. So what that is all of those are basically a layout. A good layout versus a bad one. I'm taking these layouts and changing them. So a farm layout is the relation of the fields, the gates, the lanes, the waters, the roads, etc., everything to the buildings and to the buildings to each other, as well as what is the inside of those buildings, what's going on as far as the layout of those buildings. And a desirable layout is necessary in order to economize labor and enhance the value of the property. A lot of people don't think about or care about aesthetics, but I do because it builds morale when you work in a nice place. So if I have to come in on a farm and I'm driving down the lane and I got to swerve and swish to basically miss mud puddles, that's not aesthetically pleasing. So the problem is farm layout is often given little or no consideration, which usually results in an arrangement that is neither simplistic nor systematic for labor efficiency nor livestock production. So my question to you all is do you think about planning and design? And the answer would be no, but it's something you need to think about. So greater production may be attained not only without harder work, okay, but usually with less effort simply through a better application of farm layout, design, and engineering principles. I've already showed you some. We're going to show you some more. But before we do that, we have to get on the same page, okay? So normally I ask people, what do you produce? What is your output? And people look at me like I got 2 heads, or I'm speaking a different language. It's not. I want you to get on the same page. So most people would say that their output is calves, carcasses, weight, pounds, so on and so forth. That's normally what they think. And that's fine. My perspective is no, that is not your output. Your output is grass. Okay, because the more grass you have or the quality and quantity of the forages that you have dictate how many critters you can have on your farm or how long they're going to be in a field before they get moved. So your output should actually be grass. But I'll follow you through your thought, okay, that it's actually beef and pounds and carcasses. Then what is your process for creating that beef? How do you do that? Because you're not doing it. The cow is. The cow, technically, from my perspective, is your worker. So is the calf. And so what you need to do is you need to provide products to those critters so that they can put on those pounds, so that they can produce that calf. You're not producing beef. That's ridiculous, okay? What you're doing is this. This is 1 year's worth of materials for a 1,500-pound cow. A 1,500-pound cow in a year is going to consume 62 tons of air. How much does air weigh? Practically nothing, okay? It actually weighs 0.0807 pounds per cubic foot, okay? Which is not nothing, but at 62 tons, I mean, it just kind of shows you the volume. And you're thinking, well, there's tons of air. We're breathing air in this room. No. This is HVAC. This is climate controlled. Humidity, temperature. It's also a certain number of air changes is going through this room designed on what we're doing in here as a classroom. Every building design, depending on what it is, from a factory to a mortuary, has a certain number of air changes that have to occur in that room. But let's just think about your cattle. Okay, so my cattle are outside. Steve, they got tons of air. What's the temperature of that air? What is the humidity of it? Is there any gases involved? If there's any dusts involved? Are they bringing in, breathing harmful pathogens, basically like a disease factory where they're like in a daycare where there's no ventilation and they're swapping contagions, okay? It's something to think about. Is there any shade in their fields? Those kind of things. How much light is involved? Because that also would be associated with air. 30 tons of water. A 1,500-pound cow in a year consumes 30 tons of water. How are you going to get it to her? You're going to carry it in a bucket, which is like the most menial task there is. You're going to let her drink out of some, nasty pond that's going to turn or flip over, in July and August and September and just be nasty and occluded with algae. Or are you going to set up an infrastructure of waters and pipelines to basically deliver that water throughout the farm to facilitate rotational grazing? She's going to create 23 tons of manure. The idea is, if you're actually doing rotational grazing, that an animal will actually defecate and uniformly distribute manure across a farm. That's actually not true. They're going to go underneath shade trees. They're going to go in the pond. If you've got some winter feeding areas next to a water, they're not going to leave. So you need some sort of manure handling system. They're going to consume 20 tons of forages, normally during the grazing season, which is great. From an engineering standpoint, I would like to have one cow to take a bite and have a mouthful, as opposed to having to walk over every particular area to get a mouthful, because you're actually walking off pounds off the animal. And then you're going to come in, you're going to feed 2 tons of hay to that critter and her calf during the wintertime at about a half a ton of grain, okay? And what blows my mind about this is when we feed this 2 tons of hay, theoretically, in the winter, 2 tons, that's 10% of the 20 tons of forages that they normally consume during the grazing season, but it's when we feed this 2 tons that we tear our farms to pieces. We do, every year, okay? Now, this is hundreds of tons of material being moved. What's your output? A 500-pound calf? So clearly you can look at that, and if you're creating a 500-pound calf and you have to move all this material, your job is moving materials. It's not beef cattle producer. You're not producing beef. You're moving materials. And so you need to think about, how do I need to move these materials efficiently to get it in front of your worker, which is the calf and the mama, to basically so they can reach this stuff and basically put on weight. So the major part of beef production is probably not what you think it is. It's material handling, okay? The speed of production of a farm is determined primarily by the adequacy of its material handling facilities. A good farm layout is designed to provide the proper facilities for material handling as well as for production. The production efficiency of a farm is determined by the limitations of its layout. Farm buildings should be altered or constructed around the prescribed farm layout design. So let's hit farm buildings just for a second, okay? What is the purpose of a barn or a building on a farm? Because when I go to a lot of them, I walk into this huge cavernous material, or this voluminous facility, and what do I see? I'll see a pile of wire, fencing wire, woven whatever, barbed wire that's basically taking up two-dimensional space, but it goes all the way to the ceiling because they're wasting that space. A building is not storage space, okay? The purpose of a building, the layout and the function of a building or barn should be to move materials. And part of moving materials is the storage of those materials, okay? So let's shift, okay? So right here, here's basically an illustration of an efficient family farm. Okay, I got this out of an old book published back in World War II. So from an efficiency standpoint, I'm looking at this house, okay, and these barns. All right, so what's my distance of traveling to go from the house to this barn, or from the house to this barn, or back to that barn? I got silos, I got a granary. Okay, so now I got an inventory to control, okay? This is a Gothic or Gamble type barn right here, and so I'm looking at what kind of ventilation does this barn provide, because it's choked up really tight, and so is this one. What's that air movement through these barns, okay? I got a lane that goes out to multiple pastures, which is great. You can see the shadowing, so orientation of facility is important, because I could put in the water right there and it could freeze in January and not thaw out until March, all right? I got a windmill. You can see I want prevailing wind because the hogs are over here. I don't want this hog smell coming back to the house. I want prevailing wind to carry it away, okay? So these are all this, I mean, this looks like a really picturesque Norman Rockwell-esque kind of design or illustration, but to me, that is screaming at me from an engineering standpoint, okay? So here's a barn, okay? This is the bull barn, which is on the Eden Shale property, and so I had Jacob basically do a video for me on this, okay? So here it goes. And so what happened is they actually feed row bales to the cattle that are basically being housed in this barn. And so I came up with a system of feeding row bales, and they were using their existing system. So I was like, okay, well, let's try mine, okay? So mine, we start from a designated point, and I'm running a timer, and we're obviously filming this. So what this is basically a simulated time motion study. So here he comes with this roll bale. And what I've done is I've modified this barn by cutting these holes in the side. I took this perfectly good siding on this barn and cut holes in it. And why did I do that? To basically be able to take this roll bale and stick it inside this barn on the roof, which means now that roll bale is being stored, but it's also being eaten, and it's not rotting out because it's on the roof, okay? Because you're going to lose nutritional value as soon as you stick a roll bale out in the elements. And so I timed it. So that took one guy 2.5 minutes to do. Now I said, okay, now let's do your normal route. And so here he goes with it, okay? So my way took one guy. This one is going to take 2. And I'll show you why. And it's basically kind of the same path, but it's going to change here. And so what he's got to do is he's got to back up this 85 horsepower tractor up this lane because of how the directions of the gates flow. And again, here's manure storage right here. That's got to come out. That's got to be stored as well. So he's backing down because the gates swing out the other way, so he's got to back down that way. And then he's got to have a helper because this guy's got to open the gate, but he's also got to deal with the escapes, okay? And then they got to lift this up, and lifting up that roll bale is obviously going to occlude the vision of the driver. And then he's going to take that roll bale, lift it up, and now he's going to pop it down in this ring feeder. And now where is that hay? Well, it's sitting outside, and it's sitting in this muck and mire where it's going to wick up that water and wick up that nastiness from that manure. And I timed this, so this method takes 2 guys 4.5 minutes versus my route, which took 1 guy 2.5 minutes. And I have what I call the 1% rule, because when I present this to a room of 100 people, 100 producers, inevitably I'm going to have one producer, 1%, come up to me and try to justify this route, okay? So there's that. So here's the barn the way it was before I mauled it, okay? And then this is the outside or the open section of the barn, okay? So they're mostly in here, and you can kind of look in the barn and just tell me how dark that is, and look at how much airflow that we're moving through there. Again, darkness, okay? Cattle need light. Most people don't even know how much light they actually need. But, so what we did was we just cut this in and basically rigged up. And another thing too is by cutting that hole, so these other ones have not been cut. This one's been cut. So now this is around 4 o'clock in the afternoon, and now the sun is coming in. And see, what you want to use is you want to use sunlight for multiple reasons. Sunlight is the cheapest disinfectant that you can have, okay? It's a sterilizer. But also light motivates cattle to do things, motivates their behavior. When do cattle like to eat? Dusk and dawn. Okay, they're motivated. That's basically they're crepuscular. Okay, they're motivated by that twilight time to basically eat. So in this situation, you can see there's not getting much sunlight in, and they're not getting any air movement through there. So then we come in, and it's getting close to 9 o'clock at night. Okay, and so here's the roof line on the outside. We have got sunlight shining all the way to the edge of this where the roof is. Conversely, what's going on over here? What's going on over there? There's no light, there's no air movement, okay? And that's the way that is. And then basically what we did was cut this in there, put in that what we call a little cubby, and we're going to rig this up really nice, but basically now that roll bale is in there. And now with this light and this air movement, I'm getting that requirement of air that's coming through there, but I'm also using that sunlight to motivate those animals to leave. And I also hung down survey ribbon from these openings just to show that this one's moving because there's airflow and these are not. Cattle need 62 tons of air. And really, that's the air that they breathe. In order for them to get that air, in order for it to not be respired air, where they're breathing the same air over and over again, you need to move 24 times that amount. So 24 times 62 tons. So anyway, and then now, again, so now we're using that light to motivate the cattle to move, and we're in business. And then, so here's kind of the design of that, where basically you're doing these cubbies on the roof. Here's manure storage over here. Well, ideally, you would have storage close by for the hay storage, so you're not moving very far these materials. Ideally, number one rule of moving materials is don't move it if you don't have to, okay? So there's that. And so then, shifting gears a little bit, research studies state that there's approximately 60% of the cost of owning livestock is for feed and labor. 60%. Now this is really rare for me being in research and science because it says approximately 60%. We don't do that. We say it's 59%. We say it's 61%. We never say it's approximately 60%. Why is there so much variability there? Well, because there is no standard. Okay? So if I was to poll this room and I was to say, okay, how long does it take you to feed a round bale? Well, most of you don't know because you've never measured it, so you'd be taking a guess. I don't want a guess. I want an actual number. But if you actually measured it and we took the poll of this room, okay, what research studies have found is that there is a 7-fold in one study, a 13-fold, and a 20-fold difference between how long it takes you to do the same task on a different farm. So it might take me 5 minutes to feed a round bale. Well, based on this, it's going to take someone else 35 minutes. Or 75, or over an hour and a half, because there is no standard, because where do we park and where do we put these things in order to be able to feed? Okay? So there's no standard. So that just bothers me. Okay? So there's that. Shifting gears again. Okay, so here's a roll bale, okay, round bale, whatever you want to call it. So basically, baling hay on a farm from an engineering standpoint can be one of the most inefficient things that we do on a farm. But we love doing it because we get to count how many round bales we produced. I got 100 round bales. I mean, it's a point of trophy. But anyway, if you take that round bale and you store it outside, typically what you're going to lose is 42% of the volume of that material. You're going to lose this outer 6 inches that's going to get rained on, and you're going to lose this bottom 12-inch radius. Okay, and that's where most of the volume is around the circumference of this thing. So if I've got a material that I'm storing outside and I'm losing 42%, that means I'm retaining 68, which is an F. If I'm in school, that's an F. That is unacceptable, okay? If you're losing 42% of anything, you're not doing a good job of material handling. So then you're going to take this roll bale and now you're going to go feed it, okay? So if you feed it like this, okay, where we set out these roll bales, and this is one of the UK farms where animals have full access to these roll bales, okay? So they're eating some of it, okay? And they're laying down in it. And this one right here, perfect place for it to get stomped by somebody other than its mother, which may kill it, or now you've got to doctor an animal. Now you're spending time on doing something that it's totally unnecessary, okay? This one's knee-deep, hock-deep in mud. They're going to urinate on it. They're going to defecate on it. They're going to walk and trample on this, and they're going to commingle that hay in with that mud. So my question to you would be is how much do you waste, percentage-wise, when you feed like this? And so anytime I get a question from an audience or I have a question, I hit the books and I go, what does the research say? Well, here's some research data, all right? 0% waste up to 100%. Here's the no feeder column right here. So the waste on a no feeder starts off around 36%, goes up to about 97% with an average of 58%. So whether you buy your own hay, whether you bring up your own hay, okay, if you store it outside or inside, you know, you're going to have losses that way. You're also going to have losses based on how much moisture you brought it up with. But then if you take it and you feed it in this laissez-faire system, then you can have a whole bunch of additional waste. 97%, I can take you to one of our farms and show you that all day long. It's where we overgraze a field and we unroll a round bale 150 foot in length, and they can either do two things. They can either eat it or they can lay down on it. Okay, I call it bed and breakfast feeding. All right, that's because of what it is. But here's that data for no feeder. You go over here to a ring. Now I got a nice tight cluster of data right around 20%. Okay, which means some sort of restriction on that roll bale is going to cut down on the waste. Okay, so there's that. So then this, okay, is this same area come spring. All right, and now I got calves standing in a mud puddle, which is not good for them. Hopefully they're not drinking out of it. Okay, this is looking the other way. And so this is one of the UK farms, and so I'm standing there next to the herdsman and next to the PhD that's in charge of the herd. And so I take this photo, and the PhD looks at the herdsman, and he says, Jim, how many roll bales did you feed last year? And he said, I fed over 100. And he goes, you're kidding. You shouldn't have fed more than 50. Well, there's your 50% waste, okay? And it's the math. Some people don't even figure that out, but 50% waste doesn't mean that, you know, if I'm feeding one roll bale and I waste 50%, then I'm going to feed a bale and a half. No, if you're feeding 50%, you got to feed 2 roll bales. Okay, it's weird math. But anyway, the whole purpose of developing roll bales, so to speak, or so they say, back in the 60s is when they were developed, was to save you labor. Okay, but when I think about how much is wasted by storing it outside, how much is wasted by the way we feed it, and the fact that someone's got to clean this mess up, where's the labor savings? To me, it doesn't exist, okay? This, buddy of mine, Dan, was driving down the road, said, Steve, we were talking on the cell phone. He said, Steve, I got to hang up because I'm going to need my phone to take a picture for you. I'm going to call you right back, okay? Is this a historic winter feeding area? Yes. Is it wintertime? No, it's not. And I like picking on producers, but let's just figure out or assume that there's 12 animals here, and we'll come back to this, okay? Now, here's a UK farm. I can pick on UK farms all day long. So this is one of our farms where we've been doing winter feeding. It's pugged up and plowed up pretty good. I got some liquid material running down the hill. That's a 30% slope, okay? On our side of the fence, we've basically done some feeding in these concentrated diets in those portable bunkers. You can see the plies on the truck tire. They basically rutted this up, okay? Rutted it up pretty good. Even though there's a road right here 20 feet away, they create another mud road to basically feed those portable diets, okay? On the cattle side, there's a foot of soil missing, okay? That's your productivity. Your topsoil is your productivity. This stuff is not only not over the hill, it's down in the Mississippi Gulf. I mean, it's gone, okay? But they've torn this up really good. And so I see this, and I'm like, okay, what I'm going to do is I'm going to take this area, and I'm going to come up with what I call a functional design. And a functional design for me is I'm going to save time, I'm going to save labor, I'm going to make money, and I'm going to create a better environment for the cattle, okay? And so with that, basically my idea is here's your road, okay, and here's your fence line. My idea is, why do you need to open up a gate at all? Eliminate that step of getting on and off the tractor to open up a gate, drive through, get off, and close the gate, and then try to figure out where to put a row bale. Just eliminate all that by putting in what I call fence line cubbies. These are little 2-row bale cubbies because if you looked at that site that where we're on, it fell off on that 30% slope, so I don't have a whole lot of room. But the idea with this is don't open up the gate, just basically fill in the slots. So you're not pulling up and going through the gate and go, where do I put this row bale? You put it in the empty one. It's easy, okay? So we built multiple units, okay? This one's got a roof that it may or may not need. Concrete raised feed table, concrete throughout. Same thing, just without the roof. Don't give me a hard time about that gate. This is a different version. Basically, materials plays a huge role in how much things cost. So we did steel, prefabricated feed panels on the other ones. This one's out of treated 2x6s, okay? This one we skimped on. This has basically got the plastic grid on it. And then here's just a ring feeder, a 3-section ring feeder. Unbolt one of the sections and bolt the other two, but in between 2 8-foot posts. If you're not dealing with calves, there's no reason to have a gate on any one of these, okay? Here they are, all on a line, and so what this is what we call all-weather surfaces, whether it's geotextile fabric and rock and grid, or concrete, which is essentially indestructible. It's right off the road, there's no reason to go in the fence, you get to scrape off any of this manure and stockpile it, land apply it later. You do this for the direct benefit of basically saving on hay, but you also get these ancillary benefits or indirect benefits of this is where the cows kind of like to hang out, so it's easy to check cattle, all right? This is looking the other way. In this situation, I put a gap of 20 feet in between these two structures to have the ability or flexibility of putting in two 10-foot portable panels in here, portable diets that we could feed concentrated diets on, just to give me another option, okay, of using the same rock and fabric to do something else with them, all right? Across from this area is basically a set of woods, so basically this is acting as a shelter belt to protect these animals while they're standing on this ridge to eat. I'm not feeding these animals down in the bottom where all the water drains out next to the creek because they can walk down to the creek afterwards, okay? I want to feed them where it's easy and convenient for me to get, but also not create all this mud because I'm on a well-drained summit position. Not down on the bottom that's going to receive all this water. This right here is 12 inches, so this is taken in the spring. You can see it's germinating, so that's how much they left, okay? They took this down to the concrete. So there's your waste on the inside of the structure. On the outside, well, I don't have 3 feet piled up of wasted hay because they're not wasting it because it's in here, okay? Because I'm making them stretch to eat. So there's the waste around this, all right? So then let's go to another research study. Some researcher compared a cone feeder, a ring, a trailer, and a cradle, okay? And all the body weights are essentially the same. All the body conditioning scores are the same. Same group of animals basically testing out these different feeders. So what you want to look at is this percentage of the hay waste. So a cone wasted 3.5%, a ring 6.1%, a trailer 11.4%, a cradle 14.6%. 6% waste, okay? And all of this was done on concrete, which is important, okay? And then here's your body weight for your cow in a percentage, 1.8%, 1.8%, 2%, 1.8%. So what does this tell me? This tells me that basically a cattle or a critter is going to eat essentially 2% of its body weight, no matter what you give it, okay, or how you give it to them. They're going to get their 2%. It's the design of the feeder that creates the waste, okay? In addition, this was done on concrete, which means that if it wasn't, now they're lollygagging in mud, which means you're probably going to waste some more hay because it's going to get associated with the muck and the mire. But also, if they're walking around in mud, their feed efficiencies goes down, so you have to feed more, okay? So then I thought, well, let's put some logistics to this, okay? So let's say that in a given year, a cow needs 3 roll bales of hay, okay? Well, taking into consideration the waste with the cone, instead of feeding 3 roll bales, I'm going to feed 3.11, okay? 3.2 with a ring, 3.4 with a trailer, 3.5 with a cradle, 7.14 without a feeder. And there's assumptions here, but 7.14, which means I can do these, but if I'm doing this, I'm going through that gate more than twice as many times as I would if I had any one of these, okay? All right, and that's just drudgery. Now, if I put a feed cost on there at $25 a bale, which again, this is relative, none of us measure the weight of a bale. Well, if you're buying it, I mean, there's your cost, but if you don't know the weight, then you don't know anything. If you're not testing the hay, then there's no way of comparing what kind of protein I'm getting for those dollars. But let's just go with 25 bucks a piece. With this method, it's costing me $77 to feed that critter. With this one, it's $178. So there's a difference of 100 bucks here. Easy, okay? And so then I got these, again, we base these things off our tradition. We go, well, any day that I got a cow grazing, I'm saving $1 a day. Well, how do you figure? Because there's a huge difference here, okay? And again, we're not measuring these things. So anytime you're using tradition of, well, I should be able to put an animal on 2 acres. If you're not measuring the grass production, how do you know that? Okay, if you're not doing soil samples, if you're not doing forage samples, if you're not weighing your animals, how in the world can you tell anything if you're basing it off of tradition? So let's go back to this. Let's say that there's 12 animals right there. Well, based on the system I just showed you, if I provide some sort of restriction, I'm going to save $100 per critter. If there's 12 there, that's $1,200 savings. But I have to buy the ring for the first year. So I can get probably a great ring for $200, okay? So the first year I'm going to make $1,000. Every year after that, I'm going to make $1,200, as long as that ring lasts. But then, take it one step further. Why do I need to go in the field? Why don't we do a fence line cubby? Why don't we line that fence line cubby with an all-weather surface so they're not tracking it up and creating a lot of mud and a loblolly? So these practices are mutually beneficial, but you can also see where there's savings of time and money and effort here, okay? So then so here's my fence line cubbies along this road, easy to get to. Here's my hoop barns where the hay is stored, okay? So how far do I have to drive from the hoop barn to here? Somebody say not very far, okay? But the farther that design or distance becomes, the more dysfunctional this design is, okay? Ideally, it would be right here. Now, a bad part of the design of this is that there's a 2-hole water right there. If you got feed and water in the same location, there's no reason for them to leave. So that's a problem. You can also see that this is brown, so that's manure, but I still have a green tint to my field. That's what you want. Your output is grass. You don't want to tear up your grass. This is designed not to be torn up, okay? So what we did to get rid of this problem with this 2-hole water is that there was a spring right here, an old pond. There's a spring right there, and it discharged in this pond, and basically the overflow flowed down that draw. Instead, we basically put in a tire water in between these 2 fields and use this spring to basically serve that tire water. Free water is what that is. But I'm also motivating these cows to leave this area and go get a drink and go down in the draw, okay? But again, indirect benefits, I can drive through here, or Dan and Greg can, and they can count cattle as opposed to getting on the gator and going all the way down to the bottom of the hill. All right, so then here's this, okay, and there's the hoop barns where the hay is stored. Now I got this, okay? Now this is your traditional sacrifice area. All these are basically ring feeders. They've torn this field all to pieces, okay? So set it up, all right? Now, normally, going back to the beginning, I get calls on fixing a spot problem. So a producer will get a hold of me, we'll pull up at a field, we'll go through a gate, we'll walk into that field 500 feet, and he'll go, this is where I feed, help me fix this spot with a heavy traffic pad. My question is why are you going through the gate, why are you driving 500 feet when you could feed off the fence line just on the other side of the fence is where your hay is stored. You're eliminating steps, you're eliminating distances and traveling, okay? So in this, I want you to think about where you start. Okay, so where you start is basically a hay field. So you have a hay field and you've harvested your hay. Now your hay field is basically peppered with row bales. So now you go in and you move those row bales. How many do you move at a time? 1 or 2? Or do you load them on a gooseneck, say 10 of them, and then move the gooseneck and move the tractor, and then you unload those row bales somewhere else, a staging area, indoor, outdoor, it's your choice, but you're taking losses if it's on the outside. And then, come winter feeding season, you go back to that staging area and you pick up another row bale, 1 or 2, and you go feed it. Okay? Now, what is the distance you're traveling and how many times are you picking up and setting down that row bale? Okay? My thing is this. Here's this field, okay? Turn it the other way. This guy is coming through this gate off this road and he is driving 900 feet to basically set out these rings. Okay? And he is rutting up this pasture or this lot 2 pieces, okay? My idea is basically that yellow rectangle, okay, which is basically this, okay? Go straight from your hayfield, bring your material up to this storage structure, peel off the strings, the net wrap, cover it up with a tarp, heck, put a hoop barn over it or a regular barn, I don't care. But what happens is the cattle are in this field, they come up on this concrete to basically eat, they stick their heads to these head gates to start eating this hay. And as they eat this hay, this powder blue frame basically rides back on a set of rails. So this, in this case, is a 32 row bale feeder, just only because I ran out of room with the topography. I can make it any length I want, okay? I can make it whatever width I want, okay? But the idea is these animals are serving themselves, and basically your storage structure for your hay becomes a feeder, and your feeder becomes a self-feeder, okay? So in several of these instances, with this instance right here, as well as the fence line cubbies, do you see where you could have an operation where you're feeding cattle where you don't need a front wheel assist or a 4-wheel drive tractor? Wouldn't that cut down on your costs? And then you're not tearing up your fields, which means you're not going in and having to do herbicide treatments. You don't have to buy seed. You don't have to buy fertilizer. This thing is on rails, okay? And I also have stops on these things because if I want them to eat 4 linear feet or 3 or 2 or whatever and lock it down, I can if I want to limit feed them. But why do you want to do that? You want them to eat, all right? This is also facing due south, so I'm using that sun in the wintertime when it's at a lower elevation to keep this dry. This is pitched to the left and the right, 2%, to basically get this to drain water and just keep this nice and clean. Here's your compound. So the idea is they eat like this, and then once this rack gets back to here, you can back drag all that slop, if there is any, and stockpile it out here, bring the frame back, and then reload the magazine without getting in with the cattle. Okay? And then there's a water right here. I got a 150-foot rule on waters. It needs to be further than that. So if the cattle are up here and they're eating and you take their normal path around here, I got my 150 feet. It's all about design. Okay? We had a field day. 200 people showed up to see this structure. What I want to show you is here's the cow pugging where the cattle basically approach to eat out of this structure. Here's the rutting that we did in the field. Now during this field day, people looked over here and saw this, and they looked over there and saw that, and they were like, my cattle are not tearing up my fields. I am. Okay? Now look at these ruts. Okay? Look at them. Look, look, look. Some of these are 2 feet, 2.5 feet deep. Okay? There's no chance of growing grass here. Okay? None. All right? So another thing I want you to think about is shopping. Just for a second. All right? Or you own a factory, or you go to Lowe's, Home Depot, you go to Kroger's, whatever, and you're getting stuff off the shelves. How big is the aisle that you're traveling down? It's enough room for you and someone else, okay? And that's the way it's supposed to be. You want your aisles of what you tear up to be just minimal. Well, how big is this aisle? Okay? It's ridiculous. Anyway, it's another story. So here again, ruts, cattle pugging. Who's tearing up the field? Okay? This is the amount of waste, which we did a video on this, and I noticed I started laughing when we were talking about the waste, because there is none. Okay? I mean, there's practically no residual hay left over. Okay? And then here it is too, and these are basically baled sorghum Sudan grass, and these are some regular bales. Because we didn't have this set up properly as far as like, I didn't get it built until October, and we were trying it out the day after Christmas. But here's the rails, here's the rack, and here it's coming down. Now, something I want you to point out to you. If you really believe that your job is moving materials, which it should be, okay, then what is this, okay? To me, you got to look at this weird from an engineering standpoint, or through my eyes. This right here, this black frame, okay, is what we call a bridge crane. And that bridge crane is basically moving these feed panels to access this materials. Well, where have you ever seen a bridge crane before? In every industry that has to do heavy material handling. Here's a bridge crane. Look, it's almost like round bales, okay? And what they're doing is they're moving this heavy equipment because in the industry, a crane is the workhorse for that industry, okay? Same concept. And also, too, this thing basically is running in a straight line. Well, that's how you want your cattle to move. All this business of sticking out all these roll bales in different places is not moving in a straight line. You're also not moving in a straight line if you harvest your hay here and bring it over here to store it and then bring it back here to feed it. That's not a straight line. Straight line is bringing it over here or not moving it at all and allow them to self-feed. So there's your bridge crane. So another thing to do is, let's think about this, kind of changing gears. Here's the UK dairy, and here's a field that we had basically for the dry cows. So there's two little lots right here, which really aren't even lots. There's a center fence right here, so here's a medium-sized pasture, and then here's a big one, okay? And then here's a barn for basically where they do some feeding and some loose housing. So I take that and I renovate it to basically create this. So now I've got a lane that goes down to facilitate rotational grazing with 1, 2, 3, 4 fields that are equally sized. I create a sacrifice area, which isn't really a sacrifice area. It's more of a dry lot for feeding the animals. I got my lane. I got another water down here because I'm paying attention to this 800-foot rule. And so now here's this view of this with this loose housing, with this lane, and these equally sized pastures, okay? Shade structures, and so here's basically what it looks like here. Now what I got is is this the one? Yep, got a video on this. And so this is just a drone footage showing you that what I've created is essentially what I call workstations. All right, so they got a feeding center right there. There's a water over here. There's another water right there. So watering stations, feeding stations. Ideally what you would want to do, see there's a bunk feeder right here, bunk silage. Imagine if that bunk silo was over here to basically serve those animals with that self-feeder where you never had to move a daily ration again. They're just eating it on their own. Here's my lane. And so this is like a 12-acre field. But this is what I got from the college to play with. Here's my loose housing. Here's my handling facilities. These are all components that you need on a farm. Shade, loose housing, dry bedding, feeding areas, watering areas, handling facilities, storage for commodities. Okay? And when you put these things together, what you want to do is assemble them so that you create a system where basically it cuts down on your workload, but also improves the drudgery or eliminates the drudgery of the critters. Watering station, ideally would be further away, all right? USDA chute, pick that up with federal excess property, I'm sure. But that's just the idea, okay? So that's a 12-acre field, but here's a 160-acre field, all right? What's the difference? Lanes. To be able to reach all these facilities, to be able to move one animal or a group of animals from this field to any other field without going through a second or third field, all right? To move animals from this area back up to this area without going through a second field. It's this movement of materials is what this is. This guy right here, another example. This guy's got 6 fields, okay? He's got a winter facility right there, a handling facility. He's got a hay storage right there, old livestock barn, absolutely no use. How many fields does that structure have access to? All 6 of them. All 6 of them. And that's what you want. Move animals from here to here without going through a third field. Move animals from here back to here without going through a second one. See it? See, I got a lane that connects them all. And I got these gates. All right? So then there's this. I've turned it 90 degrees just to make a point. Okay? 3 fields right here. 3 fields right here. And they're odd-shaped fields. It's Kentucky. They don't have to be square. Okay? And then I got a centralized feeding area and a lane that connects them all. You see that design? There's that design. Just cleaned up. just to make it look a whole lot easier. Now what can I do right here and here, okay? So basically what I can do is I can pop in a water right there and a water right there. So this one water, is serving 1, 2, 3, 4 fields. One water, 1, 2, 3, 4 fields. A 90-acre farm with 2 waters on it. Okay? Which means, inventory-wise, the pieces, parts that you have in your shop to work on 2 waters is negligible. Which means you don't have a whole lot of money tied up in parts. Okay? Because you don't need them. Okay? Now, this design, okay, was actually written about in the 1860s in paragraph form. This drawing is from 1910. Okay, not to make you feel bad, but this design is solid. Centralized feeding area, lane, 1, 2, 3, 4, 5, 6 pastures. Shows compass points too, because compass points are important. Okay. So, lanes, direct access with short lanes is preferable. Long lanes are unproductive use of land and may require additional expense for fencing, as well as materials, fabric, rock. So they want to be as narrow as possible, short as possible. Easy access to the farmstead also simplifies the problem of providing water for the stock. Just like the point I showed you of putting that water in that serves 4 fields, here's one water on a lane that basically serves 1, 2, 3, 4 fields. Okay? This is what we call a rendering. Drawings are great to show producers things, but here it is in real life. Okay? So not only did that one water serve these 4 fields, but they can graze that lane too. No sense in you mowing it when they can mow it for you. Okay? Here's a 4-way that we have up at Eden Shale. Okay? And these things are great. So the animals can have access to half of this, or they can have access to all this. I can use this as a catch pen. I can put an insecticide rope across this gateway to take care and control face flies as they come in. I got plenty of room in here for mineral, for portable bunkers. And during bad weather, they'll come up here and camp. Okay? And they'll hang out. And again, and it also facilitates rotational grazing. When you lay out a farm, okay, rule number 1 is you do not want to install one more gate than what you need, than what is necessary. Okay? Rule number 2 is you also want to install gates as close together as possible. That doesn't make a lot of sense to a lot of people, but look at this. Okay? I can have animals in this field right here, and I can move them anywhere of 1, 2, 3 fields, and I'm only traveling a maximum distance of 45 feet. Gates are close together. Okay? Going back to the dairy, the gates were opposing each other, so you can move them from one place to another. And there's really no movement involved. If they're in this field, then I can drive over this field anytime from 10 o'clock in the morning to whatever, 3 o'clock in the afternoon, and open up this gate. And when they come up to get water in the afternoon, they will automatically rotate over to this other field. I'm not moving anything. Okay? They go on their own. This is out of the 1950s. This is one water with a storage tank and a windmill to pump this and create this water volume. This is serving 3 fields. Okay? I just showed you a 4-way. This is a 3-way. Okay? This one right here, I have no idea how many fields this is covering, but again, this is a concrete watering tank, okay, which is a really weird one because it was poured using what we call sand form. Yeah, we'll talk more about that later. And then right here, here's the scaffolding for a windmill, and basically here's your chute. So you're using basically natural resources to pump your water, okay, and you got clean water available. They're not drinking out of a stream, okay. What year was this published? 1919. So I got one water that's serving multiple fields prior to 1919, but I can go on farms today and this is what I see all day long. One water that's ill-equipped. How many animals can this serve at one time? How many animals can this serve at one time? It's again, you're moving materials. They need to have access to these things in order to grow. Dry matter consumption is directly correlated to water consumption. If they're not drinking, they're not eating. If they're waiting in line, remember when you were a kid in school in kindergarten after recess, you'd line up at that water fountain and then that bully kid would just take it over and turn it into a camel, and then the teacher would come in just as it was your turn to get a drink and say, come in the class, we got to go, we got to work on no drink, okay? You got to have water, all right? This is on our farm. I see this every year. We put cows and calves in this field, and I've got a water that calves cannot reach. But why? Because it didn't meet the dimension standard, okay? And then this is just another, again, this is a 1960s version, but look, here's a self-feeder. Okay? Now imagine I put in manure storage over here for easy cleaning out of this. Imagine I don't have any columns in here and it's clear span where I'm not having to drive around columns to clean this out. Imagine having a lane go out to serve multiple pastures. It's not showing waters, but again, loose housing, self-feeding, watering stations, feeding stations. This is what you want to assemble on your farm. And then this is what I get. Steve, I can't afford to do this. It's too much money, what you're asking me to do. Well, without an accurate accounting of what you spend hauling materials and all the time you spend, because that $1 a day that we shot holes in, that's only for the feed. And that's not even really covering the feed depending on who you are. It has nothing to do with labor and equipment. Okay? So if you don't have an accurate accounting of how much you spend on material handling, how can anyone make an accurate assessment of what a system is worth to them in savings? And you want to consider doing another new layout if you have excessive hand labor, which is anything in livestock, okay? Improper sequence of operation, that's running back and forth like a chicken without its head. Defective farm layout, which most people don't notice and they can't see it because they see it every day and they don't notice what's going on. It's just an elusive kind of feature. The use of equipment ill-adapted to the material handling being handled. Round bales have been around for 60 years. What innovation have they come up with round bales? For feeding, for making your life easier, for letting cattle get to them. Other than that large feeder I just showed you. Unnecessarily handling materials. That's basically moving something multiple times, picking it up, and not changing really the process of that bale. Normally what happens is the bale gets worse as we go on. You slough off material as you move it. Poor or damaged materials of the product. That's basically losing 42% of a roll bale by storing it outside. Poor production time. That's animals walking in mud and taking them longer on your farm before you can get them up to market weight. Most of this is what I've gone through is what I call scientific management, and you want to address or apply these concepts on any repetitive operations and operations involving tractors or heavy equipment. Theoretically, if you own a tractor, it should be running 24/7. But that doesn't make any sense. From my standpoint, if you have a tractor, one of the first things you want to do is not use it. So you figure out, how can I cut out steps? Don't move materials, let cattle self-feed, create straight line processes, create workstations for cattle so that it's like ergonomics where they can get the stuff. Create suitable work conditions. You want to conserve cattle, the hours and energy that they spend if you want them to put on meat. You want to create service areas for shade, dry bedding, feeding areas. We already discussed all this. Watering areas, pasture, all-weather surfaces, handling areas, sick pens, and lanes to connect them all. You want to have efficient use of space. You want to make the farm comfortable, clean, safe, sanitary, and attractive. And it will build your morale as well as the cattle. So, design is a tool. I would appreciate it if you all start thinking about how design and planning can play a role in reducing your drudgery as well as the drudgery on the cattle and save you a bunch in the way of costs, which is going to do nothing but increase your profits. Any questions? Comments?
You actually look at the bulk hay feeder.
The big feeder?
Yeah.
One more time. My mouth waters when I look at this thing. To me, it does. Which you want to see the rendering, probably.
Yeah. Because in the rendering, they're stacked up, and one of the pictures they were kind of like
So Greg did them both ways. And so from my observations, this is what I saw, okay? If we stand them on end like this and you peel off the strings, when they eat it, they can peel off tons of hay, which is great because you want them to eat. But if your output is beef, okay, you want them to eat. Even though they're mamas, they need to have that body conditioning score to go full term with the pregnancy. So that's that. He also set them on end, which means they got to grab and they got to rip it off. And so I can see where some producers would make them fight for it so that they cut down on their waste. But since I got a gap in between where the feed panel is and what they have to stretch to reach, I'm not wasting anything. I want them to eat. I want them, again, I've had researchers that had to go on farms because the cows were not doing good, the calves were dying, okay? And so they went to the farm, and this guy was manufacturing the round bales so tight they could not eat. They were starving to death, literally. What's the point? I don't want them to have to fight for the food. No. I mean, it's just like the meal that we just had. I mean, are you serious? It's just not conducive for putting on, for growing. So anyway, I like it so they can cleave it off. I like it on the ends. It makes it easier to get it off. We're not wasting anything.
So is it only practical to do 2 bales high?
Really, this is actually one. It looks
Oh, that's
deceptive.
one, okay.
But it's deceptive. But it's 1 row bale high. The eating height on a cow is 6 feet.
Yeah.
And yes, we might be able to, push the limits and get some row bales up there. And if we hold our, mouth right, maybe nothing gets its neck broke or suffocated. But I didn't want to take the chance. Because again, that's significant cash. But I got some producers, like Dan, that I've done this with, and I go, are you cool with this? Now, originally when I did this, I asked him for the hoop barn to build this in. And he goes, no, because I was only going to go 1 high. But now that he sees the benefits of this and the savings that it creates, he doesn't care. He can go with 1. Because it means, for some people, it means the difference of not starting up the tractor every day to not starting it up but once a month.
Is there a cost share on this?
There is not, but there is supposed to be. They've already approached me about the concept or the possibility of adapting this in the state cost share.
So it could be.
It could be.
Okay.
But in saying that, I'll have someone run in and go, I want this. No, it's not on the books yet.
Okay. So if I want the plans for this or the cubbies or anything we've seen today, where do I find it?
So the cubbies, we have a UK extension publication called Fence Line Feeding. And the plans for, since I think all 6 models or all 5 models are in the back of it. We don't have the plans yet for this.
Okay.
The draftsman works for me and the rest of the department, so he's booked. But I've already got him working on my next design rather than come up with the drawings for this one. Because, I mean, it's fairly straightforward and simple. Yeah.
Very good.
What else? Anything? We're good? I'm good. How was it, Katie?